Hello, everyone. Today, we introduce IACS Recommendation 1.71. It explains how to manage cyber risk within the existing safety management system under the ISM code. The core message is simple safety and cybersecurity are inseparable in modern ship operations. The purpose is a practical method to assess and treat cyber risk for shipboard IT and OT systems. The process is 3 steps: define scope and collect system data, evaluate risk for each system, and implement mitigations where needed. We use common security terms: availability, integrity, and confidentiality. We also use likelihood to represent the chance of an event, impact to capture its consequences, and residual risk to describe the risk remaining after controls. Rec. 171 applies to shipboard IT and OT, including navigation, engineering, power, safety, cargo, and communication systems. Each relevant system should be included in the assessment based on actual architecture and operations. Systems are grouped by importance using URE22 categories: Category 1, Category 2, and Category 3. Category 1 has no direct safety impact. Category 2 can contribute to hazardous situations, and Category 3 can immediately threaten life, vessel, or environment. Typical maritime threats include malware and ransomware, phishing and social engineering, network intrusions, and insider misuse. Navigation-related manipulations such as GNSS spoofing or AIS tampering must also be considered. Impact measures the worst credible consequence to safety, environment, operations, or business. We assign P1 to P5, and we take the highest impact across availability, integrity, and confidentiality as the final P value. Use the impact reference table to sanity check P levels by system type. For example, propulsion and steering often map to P4 or P5. This commonly maps to P4, and gateways can be P3 or P4, depending on integrity and exposure. Likelihood reflects how likely a scenario will happen. We build it in 3 steps: determine complexity and connectivity to get the attack surface, determine user and attacker to get the human factor, then combine both to derive L. Complexity is rated from CX1 to CX3. Low-change systems are CX1, actively modified systems like network, authentication, or hypervisors are CX2, and distributed or remote-dependent architectures are CX3. Connectivity ranges from isolated CY1 to public or weakly protected networks CY5. Intermediate levels include serial or closed links, onboard networks, and authenticated external links through DMZ and VPN. Attack surface is derived by combining CX and CY using a mapping table. As complexity and connectivity increase, AS moves from 1 to 5, indicating broader exposure to attacks. User maturity and access control define US1 to US4. Strong training and individual accounts indicate US1, while poor awareness and weak physical or logical controls can result in US4. Attacker capability ranges from unintentional actors to state-level adversaries. We rate AT1 to AT5, with AT3 as a common baseline and AT4 or AT5 representing organized crime or nation-state capabilities. Human factor is determined by combining user maturity with attacker capability. Poor user practices against a capable attacker will increase H, which will later push likelihood higher. Combine attack surface and human factor to derive L on a 1-9 scale. Group L into bands for interpretation: low from 1 to 4, medium from 5 to 7, and high from 8 to 9. We calculate risk level using RL equals 2 times the sum of category, likelihood, and impact, minus 4. Formerly, RL2 multiplied by category plus L plus P minus 4, with a minimum of 1. Treatment thresholds are optional below 4, appropriate from 4 to 12, and required above 12. After calculating RL, apply selected mitigations and compute the residual risk level. RRL shows the remaining risk after controls, and it must not fall below 1. Iterate until the band meets your SMS policy. Human-related measures such as awareness training and role-based access typically reduce RRL by 1 point in the RRL step. Use this when human error or weak practices drive your risk. Organizational controls embedded in the SMS, such as change management, remote access approval, and incident procedures, can reduce RL by 3 points when computing RRL. Monitoring technologies like IDS, NDR, or NMS increase visibility and detection. When applied as a primary measure, they can reduce RL by 6 points during the RRL calculation. Hardening includes DMZ segmentation, allow listing, strong authentication, integrity checks, or data diodes. As a primary measure, hardening can reduce RL by 7 points for RRL. Combining at least one organizational control with at least one technology control enables a mixed reduction. In the model, a mixed approach reduces RL by 9 points for the RRL step. Consider this with Category 3, Impact 4. With Complexity 2 and Connectivity 3, the attack surface is 3. With users at Level 2 and a typical attacker at Level 3, the human factor is 2, resulting in likelihood 5. RL equals 2 times 3 plus 5 plus 4 minus 4 equals 16, which is required. Applying a mixed set procedures and monitoring reduces to RRL 7, moving to the appropriate band. Or central gateway with Category 3 and Impact 4, Complexity 2 and External Connectivity 5 produce an attack surface of 5. Users at Level 3 and an advanced attacker at Level 4 give H3, so L becomes 8. RL equals 2 times 3 plus 8 plus 4 minus 4 equals 22, which is required. Hardening alone reduces to RL 15. A mixed approach reduces to 13. Additional monitoring or user measures may be needed to reach your target band. Follow this cycle: inventory assets and interfaces. Classify importance. Assess impact and likelihood. Compute RL. Choose controls. And verify RRL. Document decisions in the SMS. Monitor KPIs and reassess regularly. Cyber risk management becomes a routine safety task when built into daily operations. Thank you for your attention, and CNET is always here for you to reduce the potential cyber threats you may face. Our comprehensive cybersecurity solutions are designed specifically to meet the unique demands of maritime environments. Our dedicated team is available 24/7 to address any threats you may encounter at sea. Explore our comprehensive connected solutions by scanning the QR code below for additional detailed information. CNET stands for Sea, Earth, Air Network, creating a world that connects the sea, earth, and air. Thank you for joining us today, and we look forward to supporting your cyber resilience journey. Please subscribe to our channel and hit the like button to access more high-quality educational videos and stay updated on our latest training sessions.